Okay, I want to go over some basics of physical geography for geologic processes, or what we call geomorphic processes. First, just some real basic for what we call landforms. So landforms are simply types of surface features like mountains, canyons, valleys, and so on. And if you put a bunch of landforms together, we call that a landscape, like coastal landscapes or mountainous landscapes. So really just a physical environment around us. And this is a subfield of geography called geomorphology that studies the geography of these landforms. It's closely related to geology. So we're going to be talking about geologic processes as well. A couple of terms that we use when we're describing landscapes and landforms. We can talk about topography. That's how landforms are distributed, where they are, and how they're arranged on the landscape. And also we can talk about relief. That's a difference in elevation between the highest and lowest points. So Yosemite Valley, for example, is a high relief area because there's very high places and low places relative to each other. Whereas wetlands near Los Banos are very low relief areas because there isn't very much change in elevation. So this is a way of describing the physical landscape. And so what we're interested in is how these landscapes form and what are the processes that bring them about. And they really come down to two types of processes. One called internal, or another term is called endogenic processes. Usually to make things easier, we just call these internal processes, but in the book it may describe them as endogenic. And these are processes that build things up. They increase the relief. They build up mountains or volcanoes or plateaus and things of that nature. So these include topics like plate tectonics and volcanoes and that type of thing. And at the same time, we also have exogenic processes or external processes, a simpler term. And these do something called denude, or they wear down the landscape. They decrease relief. Like, for example, erosion washes away rock and flattens it out. So again, we have the internal processes, also known as endogenic. They're powered by heat within the earth, and such as from volcanoes and magma. And we also have external or exogenic processes these are powered by the weather, and these wear things down, like erosion from water. So we're going to discuss some of the internal processes, and then later on, we're going to discuss some of the external processes. We're going to divide and conquer and look at these individually. So when we're talking about the internal processes, it helps if we understand a little bit about the structure of the earth. We have various layers of the core and mantle of the earth inside, and then on the outer edge, we have an area called the lithosphere. The lithosphere is the solid outer edge of the earth, and the outer edge of the lithosphere is something called the crust. There's actually two types of crust. There's a different kind of crust in the ocean. It's made of this type of rock called basalt, a darker rock. If you've ever seen pictures of Hawaii or been there, you might see black rock. That's basalt. That is what the oceans are typically made of. And continents are made of a lighter material. Typically, it's granite. Originally, the Earth was all made of oceanic crust, but then volcanic processes created continental crust over time. So I'll include a link to a video in Making North America that talks about that transition from just oceanic crust to the Earth being a mix of oceanic and continental crust. So continents are made of a different material that's more like granite, like the granite you would see in Yosemite. So again, the lithosphere is the outer shell of the Earth. It's rigid like rock. And on top of that, we have the crust, where we have oceanic crust made basalt. And one thing about this basalt is that it's more dense than continental crust. This comes into play when the two get pushed together. Oceanic crust, because it's heavier, ends up being pushed underneath continental crust, which is a lighter material. So continental crust here is made up of granite, which is lighter and less dense than basalt. Okay, now below the lithosphere, we have this area called the asthenosphere. And this is more molten and what we call plastic. It's more movable. And it can move very slowly. And so there are sort of this kind of movement of magma within the Earth that moves in the asthenosphere. And the lithosphere kind of rides along on top of that molten material. Just to simplify things, I like to think of it as if you've ever eaten a s'more, the asthenosphere is like the gooey middle part, and the lithosphere is like the solid graham cracker on top. You can imagine if you grab that graham cracker, you can slowly kind of move it around on top of that gooier material. And the processes that work in the lithosphere are collectively known as the geologic cycle. And the geologic cycle is all the various processes, internal and external, that create the landscapes around us. And these are also known as geomorphological processes. So geomorphological processes are sort of the geography equivalent of geologic processes. And they include two parts again, internal or endogenic processes. These include things like plate tectonics and volcanoes and the earth moving around. And we also have external processes that are driven by the weather. And these tend to denude or wear down the landscape, like erosion from rain. So we can lump internal processes into three buckets. One is a big one, it's plate tectonics. This is the global scale movement of tectonic plates, and we will discuss that in more detail as we go. Another one that's often related to plate tectonics is volcanism. These are processes that involve molten rock, either lava at the surface or what we call magma underneath the surface. And a third one is caused by the physical movement of tectonic plates, and this is called tectonism. This is about the deformation or breaking of the Earth's crust because of movements. Crust is either being pulled apart or pushed together, or sliding past each other, and causes deformation and breaking of rock. So here's a quick overview. We have plate tectonics. In some places, the plates are diverging from each other, and some places they're being pushed together. Often associated with plate tectonics is volcanism, that as plates get pushed underneath the Earth, they can melt and magma can rise and create volcanoes. Sometimes volcanoes create rock on the surface. Sometimes they create rock underneath the surface. And lastly, as plates are pushed together, you have tectonism, which is about folding and faulting, and also about earthquakes as well. That as plates are smushed together, you have earthquakes because of the pressure put on the rocks as they're pressed against each other or as they slide past each other. Some of these earthquakes happen very close to the surface. We call those shallow focus earthquakes, and some of them can happen deep within the Earth if you have processes that are moving plates down deep into the Earth's surface.